statistical process control, controlling the mean when the population standard deviation is known. We have 2-litre bottles of cola. So this bottle has slightly more than 2 litres. This one has slightly less. The target is 2 litres. Process control involves taking regular samples from the production process, random samples. We measure the sample mean, and then we plot the sample mean on a control chart to see what happens over time and to take action when needed. This is a typical control chart for the mean, where we have our target value, then we have the warning values, upper and lower, and the upper and lower action values. Here is a fully worked example. The weight of crisps delivered into a packet by a machine is normally distributed with a mean of 153 grams and a standard deviation of 2.5 grams. To monitor the process, random samples of size 4 are taken at regular intervals. We're going to calculate our warning limits and our action limits using this formula. So we know this value and this and this. They are all given in the example. What we need is a probability to work with the normal distribution, and using table 4 and a given probability, we can work out what Z is that will be used to calculate these limits. So to calculate the upper and lower warning limits, which means that if the mean is on target, we would expect 1 in 20 of the sample means to lie outside the warning limits. 1 in 20 is 5%. So 95% of sample means will lie within the warning limits. Here's a quick calculation to show that 1 in 20 times 100 to convert to percentages is 5%. And we need to calculate the upper and lower action limits using 99.8% and table 4 to work out our Z values. So we're working out limits or an interval. So when we go to table 4 and look up a probability, we have to look up something slightly different to these values. In the normal distribution, these go in the center. So what we have is this. So with 95%, 95 is in the center, but we look up 0.975 from table 4. So Z in the formula here is plus or minus 1.96. And for 99.8%, for the action limits, 0.998 goes in the center, but from table 4 we look up the cumulative probability to the left of this line, which is 0.999, which gives a Z value of plus or minus 3.09, which goes in here. Now we always use 95% for the warning limits and 99.8% for the action limits. So it's not necessary to do these sketches. All you have to remember are these Z values. So the calculation for the warning limits. The lower warning limit, upper warning limit. Calculations for the action limits. lower action limit, upper action limit. And to do the control chart, we need these 4 values and we need the target value. So these 4 values will now go onto our control chart like this. Here's the target, 153. Warning limits, action limits. Part B, state the action, if any, you would recommend if a sample gave weights off. So what will follow next are a series of samples where we have to calculate the sample mean ourselves and plot that onto the control chart and then recommend what we would do next. So here's the first sample, and remember we're taking samples of size 4. So these are not the values that get plotted on the control chart. We have to add them, divide by 4 to get the sample mean, which is this, 152.25. This is our first sample. So sample 1, 152.25, which is plotted here. This value is within the warning limits, no action required. Sample 2, again we have 4 values, add them up, divide by 4 to get the sample mean, and plot that value on the graph. Again, it's within the warning limits, no action required. Our third sample, this one has a mean of 155.5, and this time the value is above the upper warning line. So take another sample immediately. If the mean of the new sample is outside the warning limits, then we need to stop the process and take action. Sample 4, which is above the upper action limit, so we have to stop the process and take action. Sample 5, mean of 149.2, this is in between the lower warning and lower action limits, so we need to take another sample immediately. And if the mean of the new sample is outside the warning limits, so here somewhere, then we need to stop the process and take action. Part C, to comment on the performance of the process over the 5 samples. The purpose of a control chart is to show us what has happened over time, so we can look for any trends. So we can see that the mean has been increasing over the first 4 samples. The third sample provided a warning, and the 4th one said that we should take action. The 5th sample goes to the other extreme. So perhaps the machine was over-adjusted after action was taken after the 4th sample.